In this video, we're going to talk about identifying special quadrilaterals, and one thing you want to get out is your blue chart because we're going to be using that quite often. So first off, we are going to figure out which shapes or which quadrilaterals have at least one pair of opposite angles that are congruent. So to set that up, I'm going to set up a family tree like we have on our blue chart. Alright, so remember at any time if you need to push pause and write down this family tree, go ahead and do that. So for a parallelogram, we know that a parallelogram has to have both pairs of opposite angles are congruent. So because we already have both pairs, then we know that a parallelogram does fit this criteria and this condition. So for a rectangle, we know that all right angles, that we have all four of them are right angles, so it would definitely fit that as well because the opposite angles are going to be congruent. And for the square would be the same thing. So all right angles in your figure. So of course you're going to have both sets that are opposite angles that are going to be congruent. For a rhombus, the only way for this to be a parallelogram is if we also have both pairs that are congruent. So all four of those do work. For a kite, we just need to have one pair of opposite angles that are congruent. So both of those, since they are both kites, then those work as well. For a trapezoid, it doesn't really say anything about the opposite angles, only consecutive angles if it's an isosceles trapezoid. So for a trapezoid, there's not really any way for these two angles to be congruent. So it's not going to work for any of these three. For example 2, we need to figure out which one is the most specific name for this quadrilateral. And we can see that our diagonals are bisecting each other. And that is because BE is congruent to ED and AE is congruent to EC. So this tells us it is a parallelogram first. Then we need to check the fact that all four are congruent to each other, so that means that AC is congruent to BD, so our diagonals are congruent to each other. And this is more specific for a rectangle. We cannot say it's a square because we don't have right angles and we don't know anything about the four sides. We don't know anything about a rhombus because we don't know anything about the four sides. So the most specific name that we've got is a rectangle. For example 3, we have to check to see if it's an isosceles trapezoid. And first off, we need to check to see if there's any supplementary sides or angles, and that would be angle S and angle R. This tells us that side PS is going to be parallel to QR, so we know it is a trapezoid. Next, to see if it's an isosceles trapezoid specifically, we need to have a pair of base angles that are congruent. And we do have this with angle P and angle S, so yes, it is an isosceles trapezoid. For these 6 questions we're going to go through, this is to give you a good idea of what they could look like, but it's the same general idea. We need to figure out the most specific name for these different shapes. So first, for this first one, we have two pairs of consecutive sides that are congruent. Because of that, this will be a kite. For this next shape right here, we have one pair of opposite sides that are parallel. And with that one characteristic, this is a trapezoid. It cannot be an isosceles trapezoid because the diagonals are not congruent to each other. So for the next one, we see that all four sides are congruent. And the only shape that has all four sides congruent and nothing else is our rhombus. So we don't know that it's a square because we don't know anything about those degrees of the angles. For this third question, we can see that we have one pair of angles, consecutive angles that are supplementary. And this means that we have two sides that are parallel to each other. So EF is parallel to HG, which means we have one pair of opposite sides that are parallel to each other. This means that the shape that we are dealing with is just a trapezoid again as well. We don't know anything about the base angles if the base angles are congruent, so we can't say it's an isosceles trapezoid, just a regular trapezoid. For this fifth figure, we have two pairs of opposite sides that are congruent to each other. And the only figure we can say that this is true about is just a regular parallelogram. Alright, so this last one's a little tricky to notice, but we have, sorry about that, we have a triangle right here. So if I take 180 minus the 33 minus 57, I end up with 90 degrees. So we've got our diagonals are perpendicular to each other. The furthest we can go down on the family tree is just a rhombus, and that is it. And the reason it's not a square is the only way for it to be a square is if we have all four sides are congruent. And since not all four sides are congruent, it cannot be a square, so it is just a rhombus.